Okay, I think I'm live. Maybe first let's tweet about it, then we can move ahead. But right now, where is the link? Live. Here. Copy link. Okay. On today's live stream, I'm going to continue testing the account contract. Which is ERC4337. Compatible. Join me on. Hey. Okay. Now that is now that I have posted that, we can move ahead and start the okay, not this. Open folder, Foundry, open. Yes. Okay, let me start this timer. 1 hour. That is the limit for us. Okay, so yesterday we tested this the execute function, but if you see there is forge coverage. Okay, so we are right now testing this part, this contract, which is 40%. Like we have covered 40% of the statement, 45% of the lines, and 0% of the branches. So branch is anything that is in conditional, as I said yesterday. Here we are going to test the first branch, which is this revert, and see like if we get the correct what do we say, like correct revert statement. So to test that, we are going to use this thing, but instead of random address which won't revert when we send ether to it, we are going to use a custom contract that will revert every time when we send some ether to it. So how can we do that? We know that when a contract is there and you send ether to it, it either goes to fallback or receive. If there is a receive function, then that will be called. If there isn't one, then the fallback will be called. So let's write a fallback function that will revert every time. So we can call this anything, but for giving like anyone who is reading this contract, we need to give them good context, so we'll name it accordingly. So revert on called by execute. This will be the function, and this will have only one. This will be a contract, and it will have only one function, which is fallback, and it will revert with a message. Let's say yes. Uh, Receiving ether failed. No, receiving ether failed. Now what we are going to do is we are going to write a function test execute reverts with correct revert message and error. Let's see. I'm not sure how what this return data will be, but hopefully that should be this string. We'll see how it works, but right now we can create a new instance of this contract, revert on call by execute. What we can, we'll just call this same but with small r, and then new. We have the instance of that contract which will fail. Then what we can do is this same thing, vm.deal. Then this part will change, the expect revert part, which is here. We are going to use something else. Instead of the error shown above, we are going to use simple account dot the error, simple account underscore call field dot selector. Okay, now we can use this and change the address where we are sending the ether. So we have this. Now we are going to test this, run this particular test and see if we pass or we fail. Okay, fail, error is not equal to expect. Oh, okay, sorry. We also have to prank. Where is this? Okay, let's run the test again. Okay, this is not good. Let's see what happens. Okay, so revert, fallback, revert. Okay, we are getting a revert, but not this. Why is that? Okay, maybe we'll try this. Copy and change this to bytes. And that message, will this work? Not sure. Okay, that doesn't work either. So now last is we're gonna encode this ABI.encode with selector and then put this here. Let's see what happens. I'm not sure what will happen. Okay, it failed again. I didn't run this before. That's why this error is happening. EVM revert. We just remove this. It reverts. We don't get any data and we only get this error. Why is this failing again and again? Yeah, that's how we learn. Let's say. Okay, maybe I need to take help from my previous articles that I've written. The second one is testing. Now here is the unit test. Then we go down. Not here. Yeah, this was the first one. We written this, and now we are using this, and this test passed. But why not that one? Okay, maybe I need to see. Okay. Okay, there is something I'm missing. I'm not really sure what I'm missing here. All field, okay, dot selector. That's a simple account dot execute. We are sending the ether. Hex. Why is it failing again and again then? We are expecting this error, but we are getting a custom error. So what is this custom error? That's the main thing. Okay. I think I need to see some docs or something like that. Let's see like how to. Yeah. Okay, maybe just we can console log this. Console.log this selector. Okay, we didn't import the console. Okay, here we can use console. Import console to as console. Console to as console. Okay. Is it bytes? from bytes 4. Okay, can I put this? Yeah, bytes 4. Now we need to put two V's and we'll see the console here. Yeah, like it is the same error. This selector is same as this selector. Like you can see the log 329 CF16D, and this was the log here. So then why is it not working? Maybe just we can restart it. Force test -mt and then paste this, the name. Okay, there is an error. Okay, we will deal with this afterwards. Now what's the next part? So this is still remaining. Let me just switch here. VM address entry point. Okay, are we doing that? We are. Please tell me, sir. Like this won't change anything. Oh no. Sorry. Okay. No. Still something wrong. What am I missing? What am I missing? Custom error. We have given it the custom error. Okay, let's go here. And what was the thing? Like book dot get foundry. We need to see expect revert bytes for message select. Let's see how this is working. Okay, error message. We are using this like custom error dot selector, but it is still an issue. Okay, maybe for now we'll just ignore this. We are getting a revert, but not correct revert, like the revert we're expecting. Does this work now? Yes, it works, but there is an issue. Why we can't get test? Why test is not successful when custom error selector is a is added. No, customer selected is included. Okay, let's see. Now we can see the coverage, and it should improve. Yes, so you can see here we have code one branch of this contract, the simple account.sol, and we improved like the number of lines, percentage of lines, the percentage of statements, and branches, percentage of branches. So next is our validate signature function. Here we need to create like multiple things like packed user operation, and we actually need to sign the user operation and add the signature so that the signature will be here. For that, let's create a function test underscore. Okay, another thing, this is an internal function and we don't have access to it while testing. So how we are going to test it? We can go back to Foundry and see testing in internal functions. Is it here? Yes, best practice harnesses. So you can see in the Foundry work there is a best practices section, and it talks about test harnesses. So what is harnesses? Test harnesses. The harness contract is the one which we will use for internal testing the internal functions, and the original function, like the harness function, will inherit the original contract and then will expose that internal function via the external one that is in the harness contract. So as you can see here, like this is internal function, and here we have like my contract harness is my contract, and then expose internal function method. So this is external, it returns everything, it passes, like if there is argument we can pass it here by taking those inputs in the external function, then passing it to internal, and then returning any value that internal function sends to external, and external function returns it to us. So in a similar way we are going to create a simple contract harness, simple account harness. So let's call it simple account harness is simple account. Now you can see what this thing asks. So there is no arguments passed to base constructor. Specify the arguments or mark simple account harness as abstract. So what this requires is it needs to fulfill this constructor, the constructor of simple account. So we first need to create a constructor. We can just like, where is this? Yeah, we can copy this constructor, paste it here. We have this, but instead of this ownable, we'll put the simple account. We have passed, we need to pass entry point and owner. Now you can see everything is fulfilled. Next is creating a function that exposes underscore validate. Expose underscore validate signature. Function signature, like for both will be same, almost same. So copy this, paste it here, remove this part, and change it to external, remove override, and then return underscore validate will pass user op and user op hash here. Okay, we also need to import packed user operation, which is here. We also need these two, so let's import those as well. Okay, where okay, sorry, this will be source / interfaces, this will be source / chorus / helpers. Okay, now everything is fulfilled. Let's write our first function where we test if a signature is valid and it returns correct return value, which is sig validation is successful. Now let's write it. Function test validate signature returns correct value for correct signature. Like, you can write a better name. I can't think a better name on the spot, so just ignore that. Now we first need to create a user operation, packed user operation object struct. Let's select new packed user operation, and let me just paste this. Yeah, you can see this. It is simply, I'll explain what I'm doing here. Okay, ignore this error. But as we only need a signature and sender address, we don't need anything else. We can just put dummy data here. Here I'm just putting the max value of uint64 as a dummy data. We don't really need to think about it right now. For this test, we only need sender, and not even sender, we just need a signature from the owner. So owner is this particular contract. Okay, this creates an issue. Maybe not. Yes, it does. Why? I'll tell you. So for creating this ECDS signature, which will pass here, we need a private, we'll use sign function. So vm.sign, yeah, vm.sign. Now the sign text private key and the digest, but here we didn't for all of the above test, the owner is the test contract, and as you know, for a contract there is no private key, so we can't really use this function, which was the method I used previously, so I only know that. What else is there? What else? So for this test we'll change some things. Also for this test we need harness, we need a instance of simple account harness contract, so let's create that. Simple account harness equal to simple account harness equal to new simple account harness. Okay, and this needs address of entry, not address of entry point, entry point which is the argument of type I entry point, and the address of the owner. So we'll use something called VM. No, we'll use a cheat code called make address and private key. Where is this? VM.sign. No. Environment, then make address external. There should be a function make address and key. Yes, so this is the cheat code, and you can see an example how to use this here, but just as we'll use this and pass it owner, the string owner, and this will return us address, owner address, owner, and then what is UN256 owner PK, which is owner's private key. Now let's pass entry point and then owner. Oh. Okay, this is not required, which we did in the previous test, but ignore that. We need to convert it to like I entry point, add, and pass entry point. We have done this previously, so I think you know. And account harness. Okay, so this is this. Now P can we get like bytes 32? We are going to get user OP hash from entry point. Look, I entry point dot get user OP hash. Sorry, and we will pass user OP. Okay, now this is done. I think this might fail, but let's see. Now this is done. Next step is using this message utils each signed, and then actually signing the thing. Digest, I don't remember exactly. Let's see. We are getting user OP hash. Then, as I said, like we are getting this formatted user OP hash, which will format it based on EIP 712. And next step is we are going to sign it, and then encode packed the signature components. So back to this, bytes 32 formatted digest equal to, let me copy this. I'm just gonna copy paste few things which is this. Okay, now that is done, we are going to digest, come down, vm.sign owner pk comma digest, formatted digest. Now let's see, this returns v, r and s, like you can see. Okay, you can see uint 8v, bytes 32r and bytes 32s. Now we need these are components, like signature components, and we need to create a signature from this. So we need to pack above components in correct order. So we get the signature in VRS, but it needs to be packed in RS and V. So the thing will be bytes 32 signature equal to ABI.encode packed RSV. Sorry. Type bytes memory is not explicitly okay. So signature is not bytes 32, it's bytes 32 memory. Am I correct? I don't know, because previously I just used this, assigned it directly. Yeah, that also works, like user op dot signature. Okay, now what is the next step? We have this, we have all of this. We got this, we have user op, user operation, we have user operation hash. We only need to call the validate signature. So simple account dot validate export. This should be simple account harness, not simple account. And then pass user op comma digest, which is user operation hash. This is user op hash. This should return uint 256 event 256 result, and we are going to assert equal to result is signature validation successful. So all this thing is to just check if we are getting successful signature, successful return value. Dash 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 empty. Okay, let's see. Okay, where the error happened, let's see. Yep, as I expected. We can't call we can't call this. Instead, we need to use entry point now. Sorry about that. We just go core entry point is entry point. Till now the interface was fine, but now we need the actual entry point also. So let's create an instance of entry point. Entry point instance equal to new entry point. Entry point doesn't take any arguments, like constructor arguments. So entry point instance, where we can pass entry point instance which is following our entry point interface. So you can see like entry point is inheriting our entry point, so this should, the type should be satisfied here for simple account harness. Now what is next? Here we need to change this. Let's see what happens now. Does this work? Yes, everything works perfectly, as you can see. Where is you? Yes, get user operation hash. It returns this value. We sign that using private key, and it returns these components. This is what is this? This is V, R, and S. Then we are calling the exposed. Yeah, we are calling this exposed valid signature. Expose valid signature. It returns us a value. Which value is that? I think 2D. I'm not sure. It returns us a value. We check it with precompile. Oh, sorry, this value. It returns us this value. It returns us a 0. This is value of EC recover, not the exposed valid signature function. We get 0 and this is 0. Okay, now that is done. Let's go to failure case. We'll just copy this. Correct value on, or we'll change the name to incorrect signature. Here we need to change the owner is here. We'll also create a random user, like a random user, and this will be random private key and random. The only change we need to do is this. We are going to sign it with different private key, and we are going to expect sig validation field value. Now what is remaining? Okay, we can ignore this. These are just like warnings for unused local variable. We don't really need to care. This --empty flag is for checking, running a particular test, not all tests, but like a single test instead of whole file. Now let's run it and see if that works. Yes, that works. This is just warning. We can ignore this, and this is the signal. Let's see what is the coverage now for our tests. Yes, as you can see here, it's 100% for everything. So we have tested almost everything here in this scenario. Now we can go over this and see like how the whole thing works. Do we need to? But we have this. We have planned to test all the core contracts and even the utils in this scenario. But right now we are going to create our integration test. So in this, in the unit test, we are just testing individual components, like individual functions of the account contract. And in the integration test, what we are going to do is we are going to follow this whole process as okay, as I explained previously, we are going to send the whole user operation to, we are going to mimic the bundler using prank, but we are going to sign the user operation, create all the fields, generate the call data, then prank address as a user. Like we don't really need to think about the bundler software right now. We are going to run it, just not in our next test. And then we'll send it to entry point, and entry point will execute and validate everything. This will be one big test. So I think we can do that tomorrow maybe and see what happens. If you want to ignore these, remove this, then yeah, as you can see, you need to keep this comma here and here. So this tells the compiler or the extension, I don't know where I'm getting this error from, that we are only going to use one return value from this tuple. Is here its address and here is the private key. We are not going to use everything. So I think that should be it for today. We wrote 3 tests. We still haven't figured out this part of why this was failing, but we know it should revert, and it should revert on with this error. We also checked the selector for that error and it was same, but there was some issue where we couldn't figure out why we didn't get that particular error, but our assumption of this reverting was true. So maybe I'll figure that out today and let you know in the tomorrow stream. Okay, that's it. See you tomorrow. Bye bye.